In the previous units, we clarified what a system approach is, how it can be applied in practice, and why it requires interdisciplinarity and attention to scale. But what happens if you want to use systems thinking not just to understand a system, but to transform it? At that point, a whole new set of questions arises. Transformation is not just a technical matter of changing system dynamics. It is also a normative and political process involving competing visions, different forms of knowledge, and questions of legitimacy. Therefore, in this final unit, we explore why systems thinking for transformation must also be participatory, transdisciplinary, and reflexive. People may agree that food systems need to become more sustainable, but they might disagree strongly even on what that means, what should change, and who should decide, and whose interest should count. This is why system thinking for transformation requires not only an analysis, but also participation and reflexivity. As we've seen, food systems are shaped simultaneously by ecological, economic, social, cultural, and political processes. No single discipline can fully define either the problem or the solution. A transdisciplinary approach tries to address this by involving not only multiple scientific disciplines, but also actors outside of academia. Participation is important, and not just for collecting opinions. Participation helps us to improve how problems are framed, which priorities are recognized, and which kinds of knowledge are considered to be relevant. In that sense, participation supports better understanding and more legitimate action. Systems tools are especially useful in participatory and transdisciplinary settings, because they provide a shared language for complexity. As we have seen, they can make visible how different actors, dynamic processes, and scales are interconnected. They also help bring together forms of knowledge that are usually kept separate, such as ecological expertise, economic reasoning, policy experience, and farmers' situated knowledge. And when they are used well, systems mapping can generate the three types of knowledge needed for transformation. Systems knowledge, what the problem is, target knowledge, where we want to go, and transformational knowledge, how to get from A to B. By helping participants acknowledge plurality and complexity, it can encourage collective learning and truly transformative action. A final point is that systems thinking does not remove normativity. Every systems analysis involves judgments about what is included, what is excluded, whose perspectives are represented, and the desirable direction of change. These choices may be influenced by funding structures, institutional agendas, stakeholder selection, and the researcher's own assumptions. So systems analysts must also be reflexive. What is the system boundary? Who is included? What vision of sustainability is being privileged? Whose interests are left outside? The goal is not to pretend to be neutral, but to make these choices explicit and open for discussion. This is where a critical systems perspective becomes important. It reminds us that system boundaries, problem framings, and proposed solutions are always shaped by values and power relations. This final unit has shown that system thinking does not end with the analysis of complexity. When applied to food system transformation, it must also confront questions of participation, normativity, and power. Taken together, this module has shown that a systemic approach is not only a way of analyzing agricultural and food systems, but also a way of engaging critically with how they might be transformed.